Hello students, welcome back to another algebra video. You know the drill. Pause the video, try these problems in your notes, and then unpause it to do it with me. Okay, we are going to start with this problem first. Find the degree of the monomial. Now remember, monomial, because it has only one term, nothing is being added together. If this were 7c3 plus d squared, then I would have 2 terms, and this would be a binomial. But because nothing is being added together, it's just multiplication, this is a monomial. And remember, I have c cubed here, so that exponent is 3, and then I have d squared, that exponent is 2, so the total degree of this monomial is 5. So this has degree 5. Okay, being able to find the degree of a monomial helps us when we look at polynomials. So now, we want to write the polynomial in standard form. So I'm going to write my biggest exponents over here and my smallest exponents over there. So that gives me negative t cubed plus t squared minus 10t. I go exponent of 3, 2, 1. Biggest, smaller, smallest. Okay. So that is standard form. Beautiful. We want to identify the degree. The degree is the largest exponent, which is 3. So we have degree 3. And the leading coefficient is the number in front of the variable in the first term. So that is negative 1. So leading coefficient is negative 1. And we're not done yet, because it says to classify the polynomial by the number of terms. How many terms do we have here? We have 1, 2, 3. 3 is tri, so we have a trinomial here. Whoops, trinomial. We have a trinomial of degree 3 with a leading coefficient of negative 1. Wonderful! How did those go? If you need some more practice, I would recommend the practice problems from the last video. Maybe try rewatching the last video. Phone a friend, talk to your teacher. Any one of those will work. Now, on to what we have for today. Today, we continue our work with 7.1, but now we are going to add and subtract polynomials. So the learning target is you know how polynomials work together. And the success criteria is that you can add and subtract polynomials. So by the end of the day, you will be able to add and subtract polynomials. So remember, this is a review from last time. We have polynomials, which have many terms. A binomial is a type of polynomial. It's a special type of polynomial that only has 2 terms, and we call these monomials that we're adding together, we call those terms. A polynomial with 3 terms is a trinomial. The degree of a polynomial is the largest exponent, the greatest degree of its terms. And standard form goes from biggest exponent to smallest exponent. Coefficients are the numbers in front of the variables. There's your crash course from last time. Okay, so some very important information that you need to know about polynomials is the set of polynomials is closed under addition and subtraction. Now I know what you're thinking. What the heck does it mean for something to be closed? Well, a set of numbers is closed under an operation. Don't worry about that. All that means is, like, remember, operations are like adding, subtracting, multiplying, dividing. So it is closed with one of those operations when the operation performed on any two numbers in the set results in a number that is also in the set. Now, you're supposed to learn that polynomials are closed under addition, subtraction, and multiplication in your Algebra 1 class of high school. Do you know when I learned that? I did not learn that until my 3rd year of college. So, if you're like, I still don't get it, I still don't know what that means, don't worry about it. I got through 2 years of college before I truly understood what this meant. But if you can and want to understand it now, why not? So let's break this down a little bit further. The set of integers. This is the symbol for integers, and that is whole numbers. -4, -3, -2, -1, 0, 1, 2. I think you get the picture. If I add any of these numbers, I will never get a fraction or a decimal. I will always get a number in here. If I add -2 plus 2, I get 0. If I take two numbers in this set, I get another number in this set. That's all it means to be closed. In college, you might learn another definition of closed, but for now, this is what it means to be, for a set to be closed under an operation. So when I add two polynomials together, I take a polynomial plus a polynomial, I am still going to get a polynomial. Just like when I add two integers, I will always get an integer. I won't get a decimal or a fraction, I will always get an integer. So a polynomial minus a polynomial also equals a polynomial. Do you think this is true for multiplication and division? Something to think about. I'm not going to tell you just yet. I want you to think about it. Maybe try it for yourself. If you multiply two polynomials together, will you still get a polynomial? If you divide one polynomial by another, will you still get a polynomial? Don't know. We will talk about that later, but for now, what you need to know is that the set of polynomials is closed under addition and subtraction. The sum or difference of any two polynomials is also a polynomial. So if you didn't understand any of that, remember, I did not understand any of this until like 3rd year of college. So you're going to be just fine. Now, let's move on to adding polynomials. This is the first of two things we're supposed to learn today, adding polynomials and subtracting polynomials. Now, when you add polynomials, the first thing you want to do is write them in standard form. And I will show you why, but first, let's write them in standard form. So this one, this one, this one, this one. Every polynomial needs to be written in standard form. Now the parentheses are here so that we know when one polynomial starts and the other finishes. If we don't have polynomials and I just write 2x cubed minus 5x squared plus x plus 2x squared plus x cubed, I don't know which polynomial is which. I have no idea. So the parentheses are here to show us which parentheses, or excuse me, which polynomials are which. So that's what the parentheses are there for. Okay, now let's write these in standard form. 2x cubed minus 5x squared plus x. Oh, well, wait a minute. This one already is in standard form. This degree is 3, which is bigger than 2, which is bigger than 1. So this is already in standard form. But if I look at this polynomial, I have 2, 3, and 0. That's not biggest to smallest. It needs to go 3, 2, 0. So now I'll write x cubed plus 2x squared minus 1. And now, look at this. When I go to add these polynomials, the x cubeds are together and the x squareds are together. Now these we don't want together. So what we're going to do here is this minus 1, we're going to put it over here. we're going to leave space. This is like there are 0 x's. There are no x's here. So if you want, you can actually write in plus 0x. That's kind of confusing for me sometimes, so I just leave a space. But if you're like, no, I need something here, you can write 0x, and up here you can write plus 0. Because plus 0, remember, it's the same thing whether that is here or not. But it gives you a space for your normal numbers. So we have x cubed, x squared, normal x's, and normal numbers. And they're all lined up together. Because remember how you can't put apples and oranges together? Well, this is like apples, this is like oranges, these are like plums, and these are like grapes. You cannot put any of them together. I can only put grapes with grapes. I can only put oranges with oranges. So that's why we're lining them up into columns like this. And now, when we add them together, all I have to do is I take 2x cubed plus x cubed. There are 2 x cubes up here and 1 down here. So that means we have 3 x cubes down here. You just add the numbers in front of the x cubes, just like we did back in chapters 1 and 2 when we were combining like terms with our equations and inequalities. Now, let's get a different color. We have -5 plus 2. That's -3x squared. I'm going to write this all in the same color so we don't get confused. Okay, and now we have plus 1x plus 0x, or remember, you don't even have to write it in, and then it's just, 1x. So we have plus x. And 0 minus 1 is -1. There you have it. You're done. You're done. So see why it helps to write the polynomial in standard form. When you write them in standard form, you have all your x cubes already together in a row, or in a column, excuse me. And you have all of your x's together in a column. So, if you're like, ooh, yeah, this feels good, I got it, please try B on your own. Pause the video, try B on your own, then unpause it and do it with me. And if you're like, no, Mrs. Dodge, I am very confused, that's okay. We are going to do another one together. Let's get some different colors in the mix. Okay, we are going to write these polynomials in standard form. So here I have degree 2, degree 1, and degree 0. Oh, that already is in standard form. Okay, all right. 3x squared plus x minus 6. Cool. Less work for me. All right, and now the next polynomial. We have degree 2, degree 1, and degree 0. Oh, hey, that's also in standard form. Cool. So I'm going to write the x squared right underneath the other x squared. And let's see, the plus 4x will go right underneath the other x, and the plus 10 will go right underneath the other number. So now my x squareds are together, my x's are together, and my normal numbers are together. And that makes it really easy. When I add them together, I go 3 plus 1, always the imaginary 1, 4x squared, x, or 1x of course, plus 4x is 5x, and -6 plus 10 is +4. And there you have it. The end. We are done. So that is how you add polynomials. Let's make sure that we were right though before we brag. 3x squared minus 3x plus x minus 1. Beautiful. Okay. Oh yes, there's 2 different ways, vertical and horizontal. I think vertical's easier, but if you're like, hey, give me that horizontal, cool. There it is for you, and you can use that version if you'd like. But the important thing is that we got it. Correct. All right. Next, I told you that we were going to learn how to subtract polynomials, and that is also true. So same thing with these problems. We want to write them in standard form. So first I have degree 2 and degree 0. But notice over here, I have degree 2, 1, and 0. So we want to leave space for this degree 1. And if you don't know what that means, I'm going to show you. So we have 4n squared plus 5. And see how I'm leaving space for the n's. I do not have any n's. I have 0 n's in this polynomial right here. But I still need to leave space for it. Because I'm going to take my second polynomial, negative 2n squared plus 2n minus 4. So see, if we hadn't have left space for this, now we would have had like the 5 with the 2n. Well, it would just be gross. So make sure that you leave space for every term in your polynomial. So now we are going to subtract these. But remember that when I subtract a negative, this becomes a positive. And when I subtract a positive, this becomes a negative. And when I subtract a negative, it becomes positive. So basically, when you subtract polynomials, so, okay, let's go back a couple steps. Negative 2n squared plus 2n minus 4. Basically, when you subtract polynomials, you change all the negatives to positives, all the positives to negatives, all the negatives to positives. Only on the bottom polynomial, on the one that's being subtracted. And now, it's the exact same as what we did in the last example when we added polynomials. 4n squared plus 2n squared is 6n squared. 0n minus 2n is minus 2n. And 5 plus 4 is 9. So, you can see it up here a little bit better. We have minus a negative, which is positive, minus a positive, which is negative, and minus another negative is positive. That's why all of these change, and that's why we end up with plus 9 instead of like minus 9 or something like that. Okay, beautiful. So we're going to do the other example. If you're like, oh, I got this, cool, pause the video, try B by yourself to see if you really understand what you're doing or not. And then unpause it, do it with me. Okay. So, first thing I'm going to do is write them in standard form. But I think I see we have 2, 1, 0, and 2, 1, 0. So lucky for us, we don't have to leave any spaces or worry about writing them in standard form. They already are in standard form. But remember, they won't always be in standard form, so make sure you check that. Okay, so we have 4x squared minus 3x plus 5, 3x squared minus x minus 8. And then remember, when we subtract, we change all the signs on the bottom. So, the positive 3x becomes negative 3x, the minus x becomes plus x, and the minus 8 becomes plus 8. And now, we do just what we did in the last example. 4x squared minus 3 is just 1 x squared. And remember, you don't have to write the 1, you can just write x squared. Negative 3 plus 1 is negative 2x. And positive 5 plus 8 is 13. Ta-da! There you go. You have it. Let's check and make sure that we are correct. 6n squared minus 2n plus 9. And again, remember there's vertical, horizontal. I think vertical is much easier because all the terms are right on top of each other. But if you look at the horizontal form and you're like, wow, so much easier, do whichever one you want. Whichever one you want. And then we have x squared minus 2x plus 13. So we are correct. And would you look at that? Let's name him Bill. You don't want to be Bill. Bill is not happy because Bill is super confused. Look at all those questions he's got. Those questions have built up. Back from chapter 1, he never asked any of his questions, and now he's horribly confused. Don't be Bill. If you have questions, there's nothing wrong with asking questions. I was the girl that even in college, I was like, teacher, that don't make sense. Run that back. Like, do that again. And it might be annoying for the teacher, maybe, but not for me. Certainly not for me. In college, it might be annoying for the teacher, but I deserve to learn, especially when you're in college. I am paying to learn. So teach me. And if you're not teaching me, you better teach me. So same thing goes for your teachers. It is our job to teach you. If you have questions, it means that you have not fully been taught, and you deserve to have those questions answered. So please ask your question. We are happy to answer your question. All right. Here are some practice problems if you would like to practice what you have learned in these videos. These problems are like example 4, all about adding polynomials. These examples are about subtracting polynomials like we did in example 5. They might be different from the homework your teacher assigns you, so make sure that you're still doing the homework. All right, and lastly, we are gonna launch you out of here for today. So, this one comes from Diane von Furstenberg, and she says, it is so important to take time for yourself and find clarity. The most important relationship is the one you have with yourself. So, what this means, I'm gonna get a different color. Take time for yourself. The most important relationship is the one you have with yourself. You gotta be cool with you before you can be cool with other people. How do you expect to love someone else if you can't even love yourself? You gotta love yourself first before you can love on other people. And what does loving yourself look like? Loving yourself looks like showering. It looks like feeding yourself good food. It looks like exercising, taking care of your body. It looks like taking care of your mind. Going, I am super stressed out. What do I need in order to calm down and get in a better headspace? Because stress is not good for you, physically or mentally. Taking care of yourself and having a good relationship with yourself. When you think about your relationship with yourself, this is the way that my counselor told me to look at it. The things that you tell yourself in your mind, would you say those to a really good friend of yours? When you look in the mirror and you go, oh, my thighs are too big. Would you say that to a friend of yours? Would you say, your thighs are too big? No! No! You would not say that to a friend because they're beautiful. And they just can't see it, but they are beautiful. Think of that the same way when you talk about yourself. Don't tell yourself, I'm so stupid that I can't understand how to add polynomials. No! No! You just need more time. That's what you'd say to a friend. If your friend was like, man, I'm so stupid, I don't get this. You wouldn't be like, yeah, you dumb girl. No. You'd be like, just keep working at it. So talk to yourself the way you would talk to a very good friend. And think about yourself the way you would think about a very good friend. Don't be rude to yourself. Be kind to yourself. Take time for yourself to gain clarity, gain a good relationship with yourself. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.